Example 5. The table shows the results of a survey that asked men and women how many pairs of shoes they own. Letter A, make a double box and whisker plot that represents the data and then describe the shape of each distribution. So I'm going to start with men. And notice that they've already given you most of the information here. If we're making a box and whisker plot, we need the 5-number summary, which is the minimum, the maximum, Q1, Q2, keep in mind this is Q2, and Q3. They've also given us the mean of the data set and the standard deviation. And they told us how many people. So they surveyed 35 men about how many shoes they had and 40 women. If I'm going to make a box plot for the men, my minimum is at 2. Make sure you don't touch the line. My maximum is at 17. Q1 is 5. Q2 is 7. Q3 is 10. Vertical lines for the 3 in the middle. That makes your box. And then whiskers. Now, when you're making a double box plot, you also have to label on the box plot what this is representing. So this is representing your men. So we're going to label it with men. Now we're going to do women. So women I'm going to do in red. And we're going to do the same thing. So minimum we're going to put at 5, and you just put it above. Don't want anything touching. Maximum is at 24. Make it the same height, because eventually this is just going to be like a line. Q1 is 12. Q2 is 14. Q3 is 17. 3 in the middle. Make your box. Now, if you didn't quite line this up correctly, just erase it and make sure that your whisker goes out flat. You don't want a whisker that's going up. And then make sure we label that this one is your women. Now, it says to describe the shape of each distribution. Well, if I'm describing, I'm first going to look at the men. And the men to me look like they do have a tail, and the tail is out to the right. So I'm going to say that they are skewed right. Then for the women, I'm trying maybe to identify a tail here. They don't look like they have a tail, so the women, I'm going to say is symmetric. Okay, part B. Compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. Well, if I'm looking at the men, and the men are skewed right, that tells me that I should probably use the median to figure out what's actually going on here. Because if they're skewed, well, you might have an outlier or something that's going to throw the mean off. So men, if I go find the median, keep in mind that the median is the same thing as Q2. Well, that's up here, and we're looking at 7. So typically, men are buying about 7 pairs of shoes. Women. Well, women is symmetric, which means I should probably use the mean. So if I go up to the mean, and I'm looking at my women, that's 14. Well, 14 is typically the amount of pairs of shoes that women are buying. So I could say women typically, okay, this is not all, buy more shoes than men. Okay, now, what about the spread? Okay, so now if I'm going to look at the spread, I'm going to go, I am given the standard deviation, so I could look at that, but really I'm looking at the spread of my women, and the women go the whole way from 5 to, what was this, 24? Versus the men are going from 2 to 17. So if I look at my spread for the women, 24 minus 5, well, they differ by 19 pairs of shoes. versus men go from like 17 to 2, which is 15 pairs of shoes. So women typically buy more shoes, and I don't know how to really say what I want to say here. Women's shoe buying vary more than men. So some women are really buying less, some women are really buying more, versus men, you know, you've got that guy who bought 17, or maybe two guys bought 17, we don't really know, but they tend to just buy less. Now, part C, why is the mean greater than the median for men? So if we look at men, we've got men, and we're looking at the median versus the mean. Why is the mean higher than the median? And what I'm going to look at here is I'm going to look at this 17 value. Okay? Keep in mind that the mean is very much affected by higher numbers or lower numbers. So I'm going to say 17 could, and I'm specifically going to say could, be an outlier. We don't know if it is, but that's why the mean is going to be higher, because of that 17 number that's not as low as maybe all the other numbers with our box plot sitting down here between like 5 and 10.